Okay, so this is another little summary for this time section 1C, part 2A, I've put it as, which is for the iGCSE physics, movement. So we're looking at weight is mg and F equals ma. So key parts are we've got the acceleration formula, F equals ma. I prefer to write it as the ratio of force and mass. So for newtons per kilogram equals a measure of your acceleration. So how fast are you changing your motion? There's also the relationship between weight mass and gravitational field strength, which is basically the same, isn't it? But it's operating downwards towards Earth, which is when we use this terminal velocity idea. But we've got weight is mg, g on Earth is 10 newtons per kilogram, 10 meters per second squared on Earth. There are different values for different planets as well. So that's something to think about for exam questions, but you just have to know the one for Earth and then use that and then make changes from it. 3 laws for Newton. So we've already talked about F equals ma, which is the second law, this one. So the orangutan only going to get up when there's a resultant force or change in momentum. The top one, inertia. So things carry on doing what they're already doing. So if you're already sat there, you just keep on sitting there unless a force acts on you. If you are going to if you're already moving, you just keep going until a force acts upon you. So you could be traveling at a steady speed, which is slightly confusing. So Newton's first law, Newton's second law. Third law, if you sat on the floor, there's an equal and opposite reaction force of the same type acting up on the orangutan as the weight of the orangutan acting down on the floor. So you've got to have two objects, they've got to be the same type of force. Terminal velocity when you fall or drive at constant speed due to balance forces. So you get out the plane, you've got weight, you've got maximum acceleration, and as you go faster, the drag force acts up and gets bigger and bigger and bigger. But the weight eventually, they two balance out. Weight doesn't change, but drag gets more. When the drag is at its maximum value there, we will fall at a steady speed because there's no external forces acting. So the acceleration is nothing because F over m is naught. There's no acceleration. So you've got to look at terminal velocity. Stopping distance then is a combination of this sort of diagram, factors, and the graph itself for stopping distances. So think about if you are seeing a hazard and you visualize it, you think about it, you think about it, you think about it, you're still moving for a period of time, which is this top section here, this rectangle. And then I actually put my foot on the brake and I start to brake and I slow down and I stop. So the whole of the two distances added together is the stopping distance, which is also the area under a velocity time graph. So triangle plus rectangle gives me what I need. Stopping distance factors, then we need to think about if you were distracted by the passengers, you were drunk, you'd taken drugs, so you're intoxicated, that would be the same marking point. People are talking in the car, distracting the driver as well. That could be another one. So it could be any other name, form of distraction. I suppose these two are the same point. But it's noise, it's distraction. Could be something outside of the car as a distraction as well. Braking, so worn tyres, low tread pattern or grip. Ice, gravel, oil on the road. Talking about how it lowers friction is key. Worn brakes, poorly maintained, poor force on the disc. So it could be your brake fluid's gone a bit dodgy because it's hygroscopic and has absorbed some oxygen. Also, if the mass of the car is bigger and the passengers, so maybe more passengers, which could also cause more distraction, you've actually got more kinetic energy. So you've got more energy store to lose because the velocity has to be converted into thermal as we lose our kinetic energy. So you've got stopping factors, distance graphs, and distance sort of diagrams to be able to explain. And we've got all of the Newton's law stuff. That is the topic. There you go. So that's topic 1C, part 2A.